Good morning. Super excited to be here. Last year's keynote, I was part of the keynote as well. That was all virtual behind my little screen in my home office, so I'm really excited to be in person here today and talk to you all and give you guys a little bit of an update on Project Eve and what we've been working on. And also today to introduce a new member in LFEdge, which is Emerson, and Claudio's here, and I'll let him introduce himself in a minute, a little bit more about what Emerson does and why they joined LFEdge. So maybe a couple words quickly, just bring you up to speed on ZEDEDA. So the company ZEDEDA is focused on edge orchestration. We focus on distributed edge. What is distributed edge? Well, it's when you start putting tiny servers that don't look like servers in highly distributed environments that touch typically the OT world. Energy, industrial automation, automotive, these type of environments. And the company basically from its inception has been figuring out how to bring edge computing to these environments, how to enable cloud native capabilities, how to enable these enterprises to do basically edge computing to transform their businesses. We are very focused on these verticals, so that's really what we've been working on. And then as part of it, we early on realized that edge computing in these environments would require a standard. So we were actually a founding member of LFEdge. In 2019, we're really excited to be part of it. And we donated a project called Project Eve. If you're not familiar with Eve, basically think of Eve as an operating system and runtime that runs on these little tiny compute nodes that I mentioned earlier and enables you to deploy securely and manage securely these applications and tie them into the network, so offering network services, IT workloads, OT workloads, and IoT connectivity. We, as a company, have had a really great few years, a lot of great momentum behind us. What we've seen is not only great customer logos, as you see some of them here, including Emerson, but actually a lot of our customers even invested in our company because they see the strategic benefit and the capabilities of what Project Eve brings to their business. So with that, really excited to introduce Claudio and let Claudio give a little bit more background about himself, and really excited to have Emerson be part of the foundation. Go ahead, Claudio.
Well, thank you. Good morning, everyone. My name is Claudio Fayad. I'm the Vice President of Technology for Emerson. My primary goal at Emerson is actually develop our future control systems. I've been actually in the industrial automation business now for almost 30 years, the last 16 with Emerson. So I've kind of been on one of those long runners in the company. And just a little bit about Emerson. I mean, Emerson is a global technology and software company that we're part of the Fortune 200. We're $18 billion in revenue, about 80 to 90,000 people. And we've been building what we call the industrial edge for the last 3 or 4 decades. And we're going to talk a little bit about that. And now we're seeing this inflection point. We're building that as part of our automation solutions platform. We also have a second platform called commercial and residential. Even a few years ago, maybe half a year ago, Emerson was the one that actually built InSinkErator, your garbage disposal, a lot of the rigid tools. So we're a very diversified company. But we just announced a few weeks ago that we're actually divesting the commercial and residential business so we can actually become the largest pure play automation system focused on building this modern industrial edge that we're going to talk about today. So just to give us some information about it, so I think you're going to share about Industry 4.0.
Yeah, I'll go in. A couple of words. I obviously super proud to work with Emerson. If you don't know, Emerson actually invented the electric motor many years ago, and from there built an entire business around industrial automation. A great company, very innovative. But switching gears to Industry 4.0, and a lot of people talk about Industry 4.0, we talk about the fourth industrial revolution. Just to put a little bit of context, what does that mean, and how important is this, and why this matters? Basically, the other revolutions were revolutionary in themselves, right? Obviously, in the first industrial revolution, the invention of steam allowed us to improve human productivity by massive capability and everything else. The second industrial revolution was all about electricity, creating production lines and allowing us to mass produce things like whatever we use, consumption goods and everything else. The third revolution was all about computers. And you'd say, oh, is this where edge happened? Well, partially. and this is what we'll talk a little bit later about with Claudio, it's not like this is a new world. Software is not new in this space. It's been there from already 30, 40 years, but it's obviously transforming and changing. And what's happening now in the fourth industrial revolution is that we're connecting all of these things together. We're making these things smarter. We're applying AI. We're making them autonomous. We're connecting to the cloud. We're connecting machines to talk to each other, robots, obviously autonomous vehicles, all of these things. And a part of this is also the latest and greatest is the transition of energy as well, where we're going to cleaner energy and green energy. This is also considered part of this fourth industrial revolution where Emerson also plays a very big role. And so this is a mega trend. This is happening everywhere. It is, we in our daily lives are interfacing with it. And what we're basically seeing now is that the advent of cloud computing and subsequently edge computing is becoming a prime driver, enable a lot of these capabilities in there. And to Arpit's point, we actually have 5G in here as well. And we'll talk a little bit also about why 5G plays a role here. But with that, maybe Claudio, you could talk us a little bit through the current state of industrial automation and how things have been done so far.
Thanks. So, as I said, we've been building this, what we call now the industrial edge. Of course, back then, we call it many different things, automation platforms, reliability, and it was primarily built from the bottom up. Given the mission critical nature, we are actually embedded on all industries, from pharma, from refining, chemical, petrochemical. So the safety, the continuity of those productions of those plants really rely on the products we do. We were talking about real time, but we were talking about security and safety altogether. But the way it all grew up was what we call these horizontal and vertical silos. The horizontal silos, because the different systems that make the industrial edge were created separately. We had systems dedicated for process control, getting all the sensors, manipulating the data, doing all the calculations, opening and closing valves, starting and stopping motors, and making the plant run. We had safety systems. We had reliability systems that was checking the reliability of all the equipment. We had quality. We have laboratory systems that will check the samples of your product. So all those systems that were created separately. That's kind of the horizontal silos. And then for security reasons, we had layers and layers of network, none of them virtualized, all really hardware-based networks. So it was a very hardware-intensive, that was also vertically siloed. And then at some point, when we start talking about the fourth industrial revolution, people say, well, we have to get all that data together, and we started that process of connecting those things on a higher level and eventually connecting it to the cloud. But then what we realize is, even though that's a good idea, and we did made a lot of progress doing that, the fact that everything started on a silo was holding everyone back. The data that was being generated and moved was very expensive, very hard to move. So that's what we're looking at. How can we change that? The other thing, because it was created from a bottom up, it was typically the OT technologies were different than the IT technologies. We wanted to make it different because of the different requirements that we had. But now, as we see the technology kind of maturing, we actually want to leverage those to actually create a more converged environment. And all those things is what is driving us actually to the modern industrial edge. So on this next slide, what we're trying to do is similar to a lot of things that we talked about here already, right? Instead of having this traditional deployment of software, everything was on-prem, some software running on very specialized hardware. We want to now virtualize the functions pretty much like what happened with telecom and actually go a step further. So by creating, leveraging the cloud technologies, combining OT and IT technologies, deploying the software workloads, even in real time, but deploying that in an orchestrated manner, redefining the way we communicate, and I'm going to show on a chart later as well, but fundamentally moving this whole thing, those different silos, that was very hardware intensive, to become a combined, integrated, data-centric system that we can actually contextualize and share the data in a way that we can truly democratize the data across the enterprises that we serve. Security, safety is a big thing for us. So everything we do is actually kind of slowed down a little bit by security measures. You don't want to open up your plant no matter what reason it is, you don't want to be able to share the data, but at the same open up for external attacks. So that's one of the things that we have to figure out as we move forward.
Excellent. So Claudio, this is obviously, I think the vision is great. Would you mind to share with us a little bit more concrete what, for instance, Emerson, a use case, and how we're enabling all of this?
Sure, and that's one of the reasons why we just became a member of the LF Edge, because as we're building this modern industrial edge, we actually want to leverage the power of the open communities and open software as well. So we want to be working with the community, with the LF Edge, in looking into these technologies. As we look into that and actually try to solve together some of the technical challenge we have today, we're trying to fundamentally build a system that disaggregates or decouples hardware and software, where we can actually put the hardware there, and through the open OSs and leverage storage-defined networking, leverage storage-defined, software-defined storage, leverage those, creating a software-defined automation environment that leverage containers, Kubernetes, where we can actually deploy those workloads, some of them mission critical, some of them real time, some of them just with more traditional requirements. As we build that, we move away from that dedicated hardware intensive platform to a more generic hardware, software defined platform that we then allow the data to communicate in different ways. We have a lot of industrial protocols that we have created over the years that are specialized on moving data from sensors like Foundation, Fieldbus, Profinet. And one of the challenges we have is how do we get those protocols, get the data generated through that, and then actually move it on to the cloud, to the edge with more efficient protocols like MQTT, OPC Way, and RESTful APIs. So we need to create the default technology stack that will allow us to do that connectivity.
All right, so maybe talk a bit about how Project Eve concretely is being used right now in one of your businesses.
So there's one specific development that we're very excited about. We started it about 6 to 9 months ago. We expect to release it in the beginning of next year. We call it the DeltaV Edge environment, and it's a partnership with ZEDEDA, and we're going to leverage the Eve OS in there. DeltaV is one of our signature products. It's our control systems that serve all the industry out there. Several of the COVID vaccines are actually manufactured using our DeltaV control system. Fundamentally, it's the brain of an industrial operation. It's where you connect all the sensors, get all the data, pressure, temperature, flow, and actually do all the calculation to control the plant in real time by moving products around, open, closing valves, start and stop motors. We have around 11,000 installations of DeltaV, which basically mean hundreds of thousands of sensors connected, moving millions or multiple millions of data on millisecond real-time performance. Now, because of security, that environment is very, very protected. So one way for us to expand that and allow secure connectivity to the cloud and to the edge is by creating this DeltaV Edge environment, where we connect with the core DeltaV infrastructure using the data diode, so data only moves from one way to another. And we create a digital replica or a digital twin of the whole control system and therefore the plant on that edge environment, allowing data scientists and anyone actually in the plant manipulating that data, creating reports, insights, optimizations with actually touching the core that is controlling the plant, making it a very safe environment. Because of that edge environment, we want to make it distributed so you can actually control not a single instance, but all the instances in a single enterprise. And that's one of the reasons why we're partnering with ZEDEDA and using the Eve OS in there as a way to deploy workloads both as VMs or containers, and then allow the connectivity to the multiple clouds from that one. So with that, we believe our customers will benefit a lot because they're going to have more flexibility, more agility. The data is going to be easily accessible, both in terms of quantity, but also on context. So all the analysis will actually drive more powerful insights.
Perfect. This is a really super exciting use case because I think it really demonstrates what edge computing is all about. And the way we've interfaced with customers like Emerson and others, what customers want is the cloud experience, the agility, updating software, using cloud native tools, but they need to run these capabilities on-prem. And so and very, very distributed, like close to, in this case, a distributed control system or anything else. And so we've really seen Eve, I think, be adopted now to enable that, to provide that substrate, that operating system, similar to what the cloud guys built to run in a cloud. But the difference here, it's hardware independent, it's app neutral, it's cloud independent, it's network independent, it's an open source operating system. And frankly, we in the early days of ZEDEDA realized that you can't just slap Linux on a box and call it a day. That would be the easy way, but unfortunately it does not work. You need to think about security, you need to think about management, orchestration, scaling, and all of these pieces, which is really what Eve is taking Linux and making it work for these environments, just like Android took Linux and made it work on all these mobile phones, empowering basically the mobile computing revolution. This is one use case. I can tell you, over the last 12 months, Eve is now deployed in oil and gas, is deployed in renewable energy plants, wind farms, solar farms, is deployed in service center, helping to update car software, as well as read out diagnostics of cars, some of the brands that you probably use today. And we're seeing Eve really now in the industrial automation through Emerson and other partnerships going into manufacturing, in process, in discrete and everything else. So this has been a really super exciting time. And I think, just to kind of conclude, for us, it's very evident. First of all, fourth industrial revolution is happening, digital transformation driving that, edge computing an absolute requirement to enable it for these type of distributed enterprises. There's a cry for standardization in this space. A lot of companies have tried to build proprietary architectures, but they just won't work, and we need a partner with companies like Emerson. We need to understand the OT world. We need to understand what's running there. A lot of apps still run Windows in these environments, so you can't just throw containers at the problem. You have to kind of figure out how to get customers to do that migration. And things like projects like Eve really help that. And so we're pioneering this new space. We're inviting everybody who's interested to learn more to join the open source project, to participate, contribute, and we also have actually a few more sessions. So if you want to see Eve in action, being used and configured, and the hands-on part, we got sessions today and tomorrow with some of our other folks in the open source project with that. So thank you so much. Great to see you all, and thank you, Claudio, for joining me today.
Thank you. I mean, it's a pleasure to be here. Appreciate it.
Thank you.